So welcome to this Yocto Dev Day presentation. So we'll be going over some common design mistakes and suggested vector practices. So this talk will be a bit similar to the one Mohammed provided us, which was really interesting. But while he focused more on the process of developing Yocto embedded systems, we'll look more into the actual code and the bad practices I've seen. So I'm Enguerrand de Ribeaucourt. I've been working for 2 years in Savoir-Faire Linux. So it's a service company that develops embedded Linux distributions, mostly based on Yocto in varied fields for several customers. We also do other activities, so feel free to come to our booth. We'll be there the whole week and get to know us more. So this introduction will be very general. It applies to any programming language. It can be C, it can be Python, or Yocto in our case. So code smells and technical depths are two concepts that are very important in the long term for a product. So the concept of technical depth is it's not really a bug or an error that you will find in your bug. It can apply to stuff that is actually in production and works well. But it will cause maintainability issues. So some instances of code smells that lead to technical debt, I've listed some here. Duplicated code, so it's any code that you will find in two places. So of course it's really hard to maintain, because if you have a bug in one, you have to fix it, and don't forget to put it in the other place where the code is duplicated. The same will apply if you have to add new features. Another code smell is dead code, so it's code that is just comments, or code that is never built or installed or compiled. Workarounds that are not well known to the developer, so he couldn't find a proper fix, he had to make some shortcuts, and in the short term it can work well, but it will also cause issues in the long term. Bloated code, so that one is very common. It's when some part of a project starts very small, so it can be a very small script that does some installation or some update, and then we need to add features upon features, and the code becomes really complex. And at that point, it should need to have a clear architecture, which it does not, because we added the things one step at a time. And also unclear naming, which causes a lot of confusion in the code, as we will see. So other factors of technical debt will be poor performance. Your code could be very slow to build or to execute. And of course, because this code is unmaintainable, you will have trouble upgrading it, so that's a security vulnerability. But in itself, the code can be insecure because of some workaround that didn't thought out well on the security aspect. So here's a funny illustration of technical debt. It might remind you a lot about some of the projects you have seen. The dev team had to put up a house really quickly, so they made lots of shortcuts, and now the customer wants to add a window, and of course if you take one small brick out, the whole project will fall apart, so you're really stuck and you can't make your solution evolve in the time. So a few general ways to avoid technical debt. Clear planning of your project, both in the technical aspect and in the calendar aspect, are required. If you have very properly specified what your project does, how it will be upgraded, how it will be secured, you will, of course, remove the risk of technical debt. Having a clear planning on that allows enough time for the developers to properly do the job will also prevent technical debt. Having a really good knowledge of the technologies you are using, both the programming language, but also all the libraries that are linked to it, as we will see, is important. Code peer reviewing is necessary, because even if you are the best developer, you will make human mistakes, so it's always good to have a second review. And knowing a bit of code smells can also greatly help you, because it will help you identify code that should be reworked. So that's what we will be discussing today. So all the code I will be presenting comes from various developers that came to our company to improve and often upgrade the recipes. So it's actually always code that was in production, so I'll let you imagine what that could mean. And I really picked the examples that were the most signifying for me. So it was poor practices that I've seen done a lot of times by developers that are really competent, but that were usually quite new to the language. So this is my wish list of the presentation that I want these developers to see, and the next time they code, it should be of a lot better quality and help with the maintainability issues I was speaking about. So first up, we'll have a recipe. So it's from a fictional company named Acme, which does a Jetpack product. It's the third version. So we'll see the Acme name is the company name, and Jetpack 3 is the product name. So here it's an image. It does some rootfs configuration. It installs packages, and there is some compatibility machines list. So once again, this is actual code that I just made more anonymous, but I found these kinds of error often. So maybe you've already noticed some things that could go wrong here. So we'll take it bit by bit and propose better approaches. So first, I'd like to speak about the naming. So here we have a meta acme and an acme image. So I don't like this name because it indicates where the code comes from. So it comes from the Acme company, all right? But it doesn't explain the purpose of that image or that meta layer. So usually I switch the names to something that is much more explicit and that gives us a context on what it's supposed to do and not where it comes from. So usually we know where the code comes from other sources. So as stated, the names should convey the purpose, and it applies to variables, functions, file names, whatever. So I've renamed the image Jetpack 3 image, and I also renamed the meta layer Jetpack 3 distro. We'll talk a bit more on that later. So the second thing that I didn't like in that original recipe was the super admin settings, that's as stated. So they define an Acme user root home variable. So what's an Acme user? I mean, is it a user from the company, or is it just, it looks to apply to the root user, so it's not clear. And also they wanted the etc dir to be volatile. And they did all of this in a class, which is Acme rootfs, so it will pass those variables and produce the expected result. And to be honest, this class was really impressive. It was good. It was really written in a really great Yocto style. But I think that the direction that the developers chose here was the wrong one, because it was really hard to maintain. And all those features we see listed here are already implemented in the official libraries in the Yocto project. So here I replaced it in the green box. We have the root home variable to select a different root directory, and the volatile binds package that is in the main layers can get that etc dir as a volatile main point. So always search for official libraries, and they might already have the features you want. It will save you time, and these features will be properly implemented. They will have been reviewed and tested, and they will be maintained in the long run. So you will limit the risk for security vulnerabilities. So then I'd like to talk about the image install statement. So here we see that we want to install HTOP and Nano, and what seems to be the main application of that Jetpack 3 product. Actually, as it was stated a lot of times today, we want to minimize the system as much as possible. So it's perfectly correct to have HTOP and Nano in a debug image, for instance, but it shouldn't be in production. It will be harder to maintain, and also you will increase the surface of vulnerabilities. So always minimize the dependencies. And if you've paid close attention to that inherit statement, we see that it inherits debug tweaks, and maybe that sounds wrong to you. And you would be right, because debug tweaks is an image feature, it's not a BB class. So that would actually never compile. So actually, we were looking at dead code, and that's something that happened to me very often, to be reviewing and refactoring recipes that were actually no longer built in the distribution. So you have Git, rely on it. Feel free to remove dead code or past code. If you need to revert and get back to that code, you will have the Git history for that. And last, we have the compatibility machines list that wasn't right. The syntax here defines the compatibility machines for the IMX sum machine, and then it even redefines it, which doesn't make really a lot of sense. So here I don't think the developer really got what that variable was for. So the compatible machine is a variable that indicates to Bitbake that a specific recipe should only be built for a set of machines. So the right way to do what he wanted to do here, which is limit the set of machines that I want this image to be built on, will be in the green box. So using a list. And actually, the other form that we see below, it is pretty common in Yocto code, but it is made to extend an already existing compatibility list. It uses overrides. So that's what we will be talking about now. Overrides are, to me, the most underused feature of the Yocto language, and it is really vital to make stuff that is compatible with several machines or distro. So usually we use overrides in bitbake append files. So how to define overrides first? So overrides will be defined for a specific machine or a specific distro, and it will help us prevent polluting other targets and layers. So it will allow us to define variables or add files like patches for a specific machine or a specific distro. So if we take a look at how it is defined, we can use bitbake-e to see the list of override variables that are defined. So first we have the distro overrides, so it's a list, and the rightmost one is the most prioritized one. And we also have the machine overrides, and the complete solution is to have first the machine overrides and then the distro overrides, which will be more prioritized. And the way to define them is in the lower box. So use only this syntax exactly. So you have to prepend to the variable your new specified distro, and then require the parent distribution you want to inherit from. If you do it any other way, you will mess with the ordering of the variable at the end. So you should go back to these slides if you have a doubt and use this syntax. It's safe. The way to use overrides, now that we have defined them, is first in the first box, we have the simplest example of it. It is to redefine a variable for our overrides. So here we want to redefine systemd auto-enable. For instance, it can be for a security service that we want disabled in debug. So I've added a Jetpack 3 distro debug, and we want that service to be disabled. So you use the colon syntax as showed to edit the variable in the debug image. We can also not replace the whole variable, but just append to it or remove to it using the append operator. So here's an example. We have src URI append imx jetpack 3. So here we want to add a patch and a DTS file, probably for our kernel. And we want to do that only for our machine, because maybe in the future we will add more machines to our meta layer, and we don't want these patches which will not apply to our other machine, and it will be the same for distributions, for instance. The last way to use override syntax is through the source directory. Basically, you have here we have a busy box, bb-append, which will add to the file's extra path variable. And if we put the file we want to replace in a folder that is named after our distro override, it will actually replace the original one. So here we are replacing the original busybox devconfig for our customized devconfig for our distribution. So it can enable us to have, for instance, two different devconfig files, one for the release image, which will be used in the Jetpack 3 distro, and which will be tailored for debug image. So here it's done through the directory names. So of course we want to have a bit more tools that will help us debug the product, but we don't want them to be installed on the production image because we would add security risks. So here's how we use what's our generic architecture for meta layers when we start a new Yocto BSP at Savoir-Faire Linux. So we of course have the main official Yocto projects, Poki and Meta Open Embedded. Then we may have some constructor or community meta layers to add images or applications we want. And then we use usually three default specific product layers. We have a BSP layer, which contains machines. So here in this example, I added the Jetpack 3 main machine that will be used in production, but if we are in early stages of development, we may want to also have alternative hardware, for instance, one that is based on a starter kit, or it can be also previous versions of that hardware. We have a meta layer containing the applications, and we have a meta layer containing the distribution, which uses the components of the two previous ones. So, and here we usually have a distribution for production and one for debug. So it could be really tailored to your need, but that's a very generic approach that doesn't go too wrong too often. Some cases where you could want to change that, here we have a meta layer specific to our product. It's also fine to have something that is specific to our company if we want to share code between several different products. That's a bit the idea behind having an applications layer. It should only contain .bb original recipes that you are bringing to your Yocto workspace. And the idea is that it should be really easy to compile and use in other systems by defining a new distro. So you really want, through that architecture, to have absolutely zero code duplication. And also, by putting the recipes in your correct directory, you really help the developer to read what your intent is. Like I am right now specifying the machine because I'm writing in the BSP layer. So this recipe will apply to a specific machine and so forth. And don't forget that the reader developer may be one of your colleagues. And it can also be you in 1 month. So if you make the code confusing, but when you are writing it, it can be really easy to read for you. But if you leave the project for 1 month and come back to it, you really want it to be easy to read and have as little confusion and frustration as possible. So now we are going to see a few examples of code smells in custom recipes. So this recipe, the Yocto recipe itself, the .bb, was pretty fine. It's an update software from the Acme company, as always. What I didn't like, and that's why I added the sizes of the files in it, is that we have a 50 kilobytes script in it. So that was actually a 1,500 lines long bash script. So bash scripts are really hard to program properly if you want to have some error management and have some security. And that script obviously did some updating stuff. So it could flash a partition using DD, it produced logs and stored them in a specific directory. It could fetch the updates and decompress them. Of course, some features were missing. Maybe in the future you will want to have some security authentication for the package you are downloading, and that will just bloat this script more. So that's really a case where I would have recommended the developer to use an open source framework. As I've said before, really search for the open source libraries. Most of the stuff you want done is already programmed and it's properly maintained and tested. So software update in that case was a good replacement for that script. And it's really, as I said, it's something I have seen many times, having custom update scripts in various customers. So in general, I would advise, unless you are really a bash programming expert, to keep the script's length limited because it's really hard to properly handle errors in those scripts. And also, I don't think you should store complex applications in the Yocto layer. So I've seen, for instance, C++ Qt applications stored in the meta layer. And so it will work well, but it's not really the best coding style. One of the most important caveats is that you will have a lot of trouble tracking the Git modifications because if you start doing that for lots of applications, the Git management will be really complex. So keep your applications in separate directories with the README, with a clear Git history, and just add the recipe to compile and configure them in the Yocto layer. So the next slide is really a piece of art. So that's one of the worst scripts I've seen. So Ross was telling us about how to speed my build up. Well, first, don't clean the cache and rebuild things twice. So that's what this script is doing. So it starts with a very elegant comment saying that the build might fail, and in that case, I should remove my whole images dir, which there is the big README file do not destroy in this directory. Then he's doing a clean of the state cache for U-boot, Linux, and the images. Now might be a good time to advise us on how to use download caches. Why not? And then we rebuild U-boot. We then build Linux. Then we build the images. We clean one of the images we just built, and we rebuild it. So that's extremely complex, but the developer came up with this not just out of pure cruelty, but just because he had a very complex case he wanted to handle, and he came up with this first solution, which worked mostly because sometimes you have to remove the build here, and he let that thing stay that way. So of course, this is really hard to maintain. If you want to build it in CI, you have to build it several times because there is a race condition in the build. So here's the reason why he did that. Basically, it was a customer that had two hardware versions of a product, and one had a specific security modifications. So he wanted his U-boot and Linux boot scripts to sometimes allow booting without that secure modification of the hardware, and sometimes with. And of course, in production, it should never allow to switch back to an unsecure version of the hardware. So the way he implemented that is in the Linux BB file. So we see that in the do install task, he added CD. He goes out of the Linux worktree, he goes into the U-boot worktree, and then he edits the source like a maniac because every endif is replaced with define secure. Then he builds U-boot. He uses OE run make, which is really great. He could have just used make, which doesn't pass the compiler flags, so cheers to that. And then he concatenates the result of the U-boot binary, he puts it in a secure image, he reverts the sources, and if you look back at the previous slides, then he goes back to building Linux. So he built U-boot, then Linux. So what he wanted to do here is have two variants of U-boot, one that accepts the unsecure hardware and one that doesn't. And here I think that the overrides are really the typical way to do that. So you have a debug distro override and a secure distro override. And you produce two separate U-boots with their own sources, with the DS-defined secure and the other one without. And then you're good to go. You don't have any build issues and race conditions in your build. So lastly, there was an insane skip, of course, inherit. And the developer was kind enough to remind us why. So that's actually a code smell. It's a workaround that tries to disable warnings or error in the Yocto QA process. So please keep the QA process and actually fix the errors. So here, in this case, he wanted to increase the temperature, the limit in temperature that the system accepted because it could run in a lot of heat. Why not? But actually, by disabling the skip, by disabling the QA issue, he missed the point that his script was no longer correctly applied, and so his configuration wasn't good. So to sum up, here are some tips that I explain here. So do not get discouraged. Really try to understand the code that you are writing in Yocto. I know it's very challenging, but also when you have to patch the Linux directory and drivers. But any code that is produced and actually runs in customers' hands should be understood by the developer, of course. And so the first solution that works may not be the best, so take the time to think on the architecture of your code and to refactor if needed. Also, so I've said it already 2 times, let's go for a third. Search for official libraries and examples. You will save a lot of time and have a lot more stability and security. Linters and code review can help you fix errors before they happen in production. Overrides are a very central aspect of the language. You should use overrides almost everywhere when you are customizing recipes that already existed, so that you do not pollute over layers, and that will help you remove code duplication, because you can specify the differences without having to redefine the whole recipe. So yeah, that's one of the main concepts in programming, the KISS concept: keep it simple and stupid. If your code looks complex, and even you yourself are having a hard time understanding it, it's probably that it needs refactoring. So have a look at the code, and if you see any code smells, so I've reminded the list here, it could be an indicator that your code will have some maintainability issues. So take the time to read it and improve it. So thank you for your attention, and feel free to contact me or ask questions right away.